Good day, everyone. For today's lesson, we are going to explore the world of electricity and electronics. And it is vital to start by understanding the basics of voltage, current, and resistance. These are the three basic building blocks required to manipulate and utilize electricity. Let's recall electricity is the movement of electrons. Electrons create charge, which we can use to do work. Our light bulb, our phone, or any gadget or appliances are all harnessing the movement of electrons in order to do work. They all operate or function using the same basic power source, which is the movement of electrons. I have here an illustration to show the relationship of voltage, current, and resistance. As we can see, the voltage causes the movement from one point to another point called the current, and the resistance tend to slow down the movement of the current. Now let's expand our knowledge about voltage. It is the charged electron or the pusher. Voltage causes current to flow or move. Voltage resources, we have battery, generator, outlets. Symbol for voltage is capital letter V or sometimes capital letter E. And the SI unit for voltage is volts, and the symbol is capital letter V. Thanks to Alessandro Volta for his contribution to electricity. He is an Italian physicist known especially for the invention of the electrochemical cell, also known as the battery in 1800. Voltage at home. Power utilities use large generator to provide the 110 volts or 220 volts that is delivered to our home outlets. When we plug in something to the outlet like lamp, blow dryer, TV, or any other appliances, the voltage is applied across the circuit, allowing the charge to flow, which is called the electric current. Okay, let's differentiate these two terms, electromotive force and potential difference. Electromotive force is a potential energy, stored energy given to a unit charge to make it flow through a conductor or around a complete circuit. While when we say potential difference, it is similar to EMF. However, potential difference is an actual consideration of potentials in the circuit. The existence of potential difference also identifies the flow of charges through the circuit. So we have here a table. Again, EMF is the source energy or stored energy that will supply electricity in a closed circuit. It is independent of the resistance of the circuit because there is no moving of electrons yet. And the term EMF is used only for the source of EMF. While when we say potential difference, it is proportional to the resistance between the given points. Affected man siya reduce ang voltage sa pressure sa electrons as it moves because of the resistance. If atong source kay 50 volts, therefore mahimo na lang, ma-reduce na lang siya kay depende sa need sa gadget or appliances. However, it is greater than EMF when the cell is being charged. So if mag-charge ta kay mag-store ta og energy, let's say atong power bank kay dako taas ang capacity to store energy. This time, let's talk about current. It is the flow of charge within a conductor or how fast charge is moving. Charge will only flow if there is a voltage source. Yes, voltage can exist across a circuit without current, but current cannot exist without voltage. Symbol for current is I, or the intensity. Unit for current is amps. Symbol is capital letter A. And thanks to André Ampère, a French physicist and mathematician, one of the main discoverers of electromagnetism. That's why the SI unit of measurement of electric current, the ampere, is named after him. What level of current is dangerous to us? 0.001 amps can be felt already. 0.005 amps, painful. 0.010 amps, involuntary muscle spasm. 0.015 amps, loss of muscle control. And 0.070 amps, likely fatal if it's lasts more than 1 second. So if we are working or if we are doing something involved electricity, we need to be careful. Solving time. Electric current is computed using this equation. 1 is equals to Q over T, where I stands for the current in ampere, Q amount of charges that pass through the conductor in coulomb, and T is time in seconds. Let's solve example number 1. Compute the current produced by a 6.5 times 10 raised to the power of 18 coulombs charge flowing in 15 seconds. Input the given and being asked in the problem. We have Q, which is 6.5 times 10 raised to the power of 18, and T is 15 seconds. Input the formula and substitute the value of Q and the value of T. Get the quotient, divide 6.5 times 10 raised to the power of 18 and 15 seconds. So the answer is 4.33 times 10 raised to the power of 17 coulomb per second, and coulomb per second is equal to 1 ampere. So therefore, the final answer would be 4.33 times 10 raised to the power of 17 amperes. Example number 2, a steady current of 0.6 amperes flows through a wire. How much charge passes through a wire in 1 minute? So given, input the given and being asked in the problem. T is 1 minute, and remember, in the formula, this should be in second. So 1 minute is equals to 60 seconds, and electric current is equal to 0.6 ampere, and the unknown is the charge or the Q. Solve the problem using the formula. I is equals to Q over T. Substitute the given. We have the value of I, which is 0.6A, equals, leave as it is because Q is unknown, over 60 seconds. Cross multiply. Q times 1 is Q equals 0.6 amperes or 0.6 coulomb per second times 60 seconds. Get the product, or times 0.6 and 60. That is 36. Cancel out seconds. Therefore, the final answer would be Q is equals to 36 coulombs. We are down to the last concept, which is resistance. Resistance opposes the push from the voltage source. Resistance affects the speed of the current. Symbol for resistance is capital letter R. Unit for resistance is ohms, and this is the symbol omega. Therefore, resistance and electric current is inversely proportional to each other. And thanks to George Simon Ohm, a German physicist, Ohm determined that there is a direct proportionality between the voltage applied across a conductor and the electric current. This relationship is known as Ohm's law. That would be our next lesson. Now, what factors affect the resistance of a wire? So, these are the common factors. Length of a wire. The length of the wire is proportional to the resistance, to its resistance. The longer the wire, the higher the resistance. And cross-sectional area, this is the area of the wire, is also will affect the resistance of a wire, because it is where the electrons will pass through from this phase to the opposite phase. And cross-sectional area is inversely proportional to resistance. The bigger the area, the lesser the resistance. So, kung magkadako ang diameter sa atong wire, magkagamay ang resistance kay makamove freely raman ang electrons. Material, of course, it will affect the resistance of a wire. And we have here another factors that will affect resistance and current flow. Electrical resistivity and electrical conductivity. It is a fundamental property of a material that quantifies how strongly it resists or conducts electric current. Good conductor, that means low resistance. Bad conductor, that means high resistance. Observe the pattern. If we have if electrical resistivity increases, effects on resistance increases also, and effect on current flow decreases. It's the opposite. If the electric resistivity will decrease, resistance will decrease also, and effect on current will low. If electrical conductivity is higher, effects on resistance will decrease, and effect on current will increase. And if its conductivity is lower, resistance is of course higher, and effect on current flow will decrease. Temperature will also affect the factors on resistance, effects on resistance, and effects on current. Why? Because more siya highway class, ikaw ang driver, no? If init ang panahon, the higher the temperature, the more violently the atoms vibrate, or the more collisions are caused, the greater the resistance to current flow. Kay irritated man ka, so munang dili kayo smooth imuhang dagan. The higher the temperature, effects on resistance increases, and on current flow decreases. If lower temperature, decrease ang resistance, effects on current flow mo increase, kay condition man kay ka. Now, length of conductor. Katason sa conductor, if the longer the conductor, effects on resistance will increase, and effects on current flow will decrease. The shorter the conductor, the effects on resistance will decrease, and it will increase on the effect of current flow. Lastly, the cross-sectional area. I've done discussing this concept already. The bigger the area, the lesser the resistance, and on the effect on current flow, it will increase. And the smaller the area, cross-sectional area, the bigger the resistance, or the higher the resistance and effects on current flow, it will decrease. Now, let's understand deeper this concept, electrical resistivity. It is an intrinsic property of the material that describes how it resists the electric current flowing through it. If we are to associate this concept to our life, electric current would be the temptation, and when we say resistivity, it is how we control ourselves to resist temptation. Now, we have here resistivity of various materials. For silver, its resistivity is equivalent to 1.59 times 10 raised to the power of -8 ohm meter. For copper, we have here 1.7 times 10 raised to the power of -8, and Also, we have quartz, 75 times 10 raised to the power of 16 ohm meter. Resistivity is computed using this equation. R is equals to this symbol times the length, the resistivity, times the length over the cross-sectional area, where R stands for the resistance in ohms. This symbol stands for the resistivity in ohm meter, and L stands for the length in meters, and A stands for the cross-sectional area in square meters. Let's solve example number 1. Compute the resistance of a conductor given a resistivity of 10.4 ohm meters, length of 4 meters, and cross-sectional area of 7.85 times 10 raised to the power of 3 meters squared. Input the given and being asked in the problem. We have here the resistivity is equals to 10.4 ohm meter, and length is 4 meters. Cross-sectional area is 7.85 times 10 raised to the power of 3 meters squared, and the unknown is the resistance. Input the formula and substitute the resistivity and the length divided by the cross-sectional area. Cancel out meter, and get the quotient. 10.4 divided by 7.85 times 10 raised to the power of 3. We have 0.005299 ohms, and the final answer would be, in scientific notation, R is equal to 5.30 times 10 raised to the power of negative 3 ohms. Example number 2, a copper rod is 3 meters long and 4 millimeters in diameter. Solve for its resistance. Provide what are the given and being asked in the problem. We have here the resistivity of a copper rod is 1.7 times 10 raised to the power of negative 8 ohm meters. Length is 3 meters, and take note, in the problem we don't have the value of cross-sectional area. So for us to get the area, this is the formula, pi r squared, and what's given is the diameter in millimeter, which is 4 millimeter, and remember this should be in meters. So 4 millimeters is equals to 4 times 10 raised to the power of negative 3 meters. And since in our formula R is needed, therefore just simply divide 0.004 meters. This is the decimal form of this one. Divide this one into by 2. Divide this one by 2. We have 0.002 meters because radius is just simply half of the diameter. So R is unknown. Input the formula and substitute the formula for us to get the area. Now you could have another two-way process for this. You can solve first the area and then use this formula, but I want to have all-in-one process, so I will be using this formula instead. This is just the substitution for us to get the value of area. Substitute resistivity times the length, which is 3 meters, over value of pi. We have the value of constant value of pi, which is 3.1416, times the value of r, which is 0.002 meters squared. And cancel out meters. This could be meters squared, but pwede rasad dili na to simplify, no? Get the quotient. 5.1 times 10 raised to the power of negative 8 over 1.26 times 10 raised to the power of negative 5. So the answer is 0.004047. In scientific notation, our final answer would be 4.6 times 10 raised to the power of negative 3 ohms. Let's have a wrap up first before this discussion ends. This is another way to illustrate the concept of voltage, current, and resistance. So here is a water tank. The amount of water is the charge. The pressure is the voltage, because the more water, the more pressure. The lesser the water, the lesser the pressure. And the flow of the water is the current, and the hose width is the resistance. And that ends our lesson for today.